Welcome to the cloudonaut podcast. We are your hosts, Andreas and
Michael Wittig. We have been building on AWS since 2009. Follow along as we develop products like bucketAV, attachmentAV, marbot, and HyperEnv. This is episode number 95, and we are recording this on August the 21st in 2025. In case you're watching this live on YouTube or LinkedIn, feel free to ask questions in the chat, and we will answer them either directly or at the end of the show. So, Andreas, let's dive into the topics, right? So, I'm starting with I would say, a cost reduction kind of journey I went through, and I post a link to the blog post in the chat now. So basically, what we observed in one of our AWS accounts that runs Marbot is that we had a significant portion of our bill caused by AWS Config, which is basically a very foundational security service that kind of keeps or stores configuration changes of your AWS account. So I was a little bit annoyed by the factor that we paid so much money to a service that does very little to our product at the end. And also the bill was just growing and growing and growing, and we constantly hit our budget for months, and I think it was actually for years, Andreas. But so far I was too lazy to investigate. So this time I looked into the details a little bit, and I figured out that if you have a volatile workload, which I define, for example, as EC2 instances running in an autoscaling group on spot capacity, which means they are regularly terminated and created and so on and so forth, or if you have a fleet that is heavily auto-scaled, this would be a volatile workload. Also, if you spin up resources just for a short amount of time in a VPC, for example, in our case, it was Fargate tasks. Like we were launching very tiny Fargate tasks for every customer, every hour. Basically in Marbot's case, we run Terraform for each customer account region to apply AWS CloudWatch metrics, for example, or changes to them, things like that. So usually the task runs for maybe 30 or 60 seconds. But every time a task on Fargate is created, an ANI is created, which causes in AWS Config a bunch of resources to be created, or what they call configuration records to be created. And you pay for all of them. And yeah, that's why our config bill was so high, because we had so many configuration changes during the day. So a couple of searches and investigations later, I figured out that there are two ways to run AWS Config. The default mode is it runs in a continuous mode, which basically means it records every single change during the day, which is fine if you have a workload that is not changing much, right? But in our case, that was causing troubles. So I figured out that there's also a mode called the daily recording mode, which just takes a snapshot once a day. And only if there is a change to a resource, it records it. So that was basically interesting to me. So I switched the value from continuous to daily. And all of a sudden, our AWS config bill was basically zero, Andreas. Because we don't have many changes that last for a day. So the amount of changes that AWS Config now detects in our Marbot production account is mostly zero. That's the quick summary of what I did. There are other options and optimizations that you can do if you are in a similar situation. Let me first start with why we have AWS Config enabled at all. And this could be also reasons for many other AWS customers, because we use AWS Security Hub, and AWS Security Hub heavily relies on AWS Config to make its checks. So you are kind of forced to enable AWS Config. Luckily, Security Hub is happy with the recording frequency of daily, at least at the moment. So you can change it to daily in AWS Config, and Security Hub still is happy. There are no alerts, no security issues found by Security Hub. So that's fine for us. What you could also do, if you just want to reduce the frequency, for example, for elastic network interfaces, which also causes changes to VPC, subnet. I think those are the two. That's another third resource I cannot remember, but there are 4 changes actually when an ANI is created. I think security group is the 4th one. So those 4 resource types are changed every time an ANI is created. So you could also change the recording frequency to daily only for those 4 resource types. So there are filter possibilities within resource types and change only those to daily, for example. So if you want to keep your IAM, for example, configuration recorded continuously, you could do that. You either can have the daily default and then specify like whitelist or allow list the continuous stuff, or the other way around, have everything in continuous mode and just set ANI, VPC, subnet, and security group to daily. So that would be an option as well, as kind of a balance between keeping all the changes and reducing your config bill. Mm-hmm. So that's it, Andreas, basically, from AWS Config.
Yeah, so I think one thing is the disadvantage of disabling the continuous check or the continuous recording is that, of course, you're losing data. So in theory, you're missing then, I don't know, a misconfiguration that would otherwise cause a security hub rule to trigger or something. So I think that's the disadvantage of doing that. And the reason for all that is basically the pricing model of AWS Config is just, I think it doesn't really, so if you have a very volatile workload as you described, it just doesn't match with the pricing model that they have behind all that. It doesn't generate the value that you have to pay for. That's
And I mean, in our case, it was maybe $4 a day or so. Someone on LinkedIn, I posted the blog post on LinkedIn, and someone on LinkedIn said that he just saved $12,000 a month or something for his AWS config bill. So if you really run, and I think this was in Elastic MapReduce or something use case. So if you have really workloads that spin up a lot of ANIs, basically, it gets really expensive. And it was actually, Andreas, in our case, it was more expensive than the Fargate task itself. So the AWS config costs were higher than the workload cost, which is really, I mean, that's not balanced in any way. So
Okay. Yeah, very good that we have, that you have optimized that. So always good to find those little things in our cloud.
I mean, I think for us, at least in the long term, I said I think I saved around $4 a day, which is $1,000 per year, which is if you run your own company. This is, I mean, it's money that you don't spend, so that's nice for us. It was worth the couple of hours investment that I did. I mean, I also wrote blog posts and stuff like that, so that was some additional effort. But the investigation and changing the flag was basically very simple. And very quick. So all right,
perfect.
The second topic, Andreas, I think it's also my topic, if I can see that correctly. Okay, so this is in a different direction. I post a link to the blog post in the chat as well. A couple of months ago, I was looking into an issue with our S3 malware or antivirus detection solution, bucketAV, which was running fine on T3 Nano instances so far on Amazon Linux 2. But then we switched to Amazon Linux 2023, and all of a sudden it didn't work anymore. And if I logged into the instance, I either was not able to actually log in because it was so slow, and if I was able to log in, it was just painfully slow. And I mean, it was so slow that you basically had no way to kind of figure out why it is so slow, because it was so slow. So this is a little hard because sometimes I just typed something and then it took a minute, and then after the minute I saw the character on the terminal. So this was kind of the level of slowness I experienced. So basically very, very slow. So it took me some time to figure out what the problem was. Quickly I realized that I had some, or likely the problem was caused by the memory usage. So I wasn't sure, okay, why is so much more memory used on Amazon Linux 2023 compared to Amazon Linux 2? Because our application was the same. So, I mean, only the operating system changed. I mean, only in quotation marks. But what I figured out is actually two things that are important if you run tiny workloads or on tiny instances like the Nano instance type on Amazon Linux 2023 compared to Amazon Linux 2. The first one, which could be an issue or couldn't be an issue depending on the usage of the temp directory. So /temp is typically where you store temporary files that are very likely not stored if you reboot the instance. So if you reboot the instance, those files usually are gone. In Amazon Linux 2023, temp is actually backed by tempfs, which is backed by memory. So if you access temp, it's really quick because it's on memory. If you reboot instance, everything is gone because it's on memory. But I mean, it needs memory, right? Because it's backed by memory. So in our case, for bucketAV, when we download a file, we store it in the temp directory, and then it just put the file into memory. But we don't have much memory on a T3 Nano, so there was some issue, because then we swapped. So the operating system tried to move memory to disk. And this is where actually the second issue is coming from. So swapping. In Amazon Linux 2, if you swap, it is stored on disk. In Amazon Linux 2023, there was a change that was not there from the beginning. It was introduced kind of midway in the journey. They now have something enabled for instances with less than 1 GB of memory, which applies to the T3 Nano family mostly, instance type, includes T3A and T3G Nano instances. And this is called ZRAM. And ZRAM is, in my very simple words, a swap place or swap space backed by compressed memory. So basically what the operating system does using ZRAM is it takes the memory, it compresses it, and it stores it in memory again, but it needs less space because it's compressed. If you access it, it decompresses it and moves it back into memory. So compressing and decompressing is very CPU intensive. There's not a lot of CPU on a T3 Nano available, unless you can burst above your 10% of a core, which was in my case obviously not possible because some other workloads were running on T3 and at other like on the host machine. So I had a very slow CPU. I also had very less memory, so there was a lot of compression, decompression going on, and so on and so forth. So that was the second problem. Luckily, you can disable both of them. You can move temp back to disk, you can move swap back to disk, and then you're fine, and it's just running as before, Andreas. So yeah, keep that in mind when running tiny workloads on tiny instances on AWS. The blog post has like detailed instructions and commands that you run on Amazon Linux to make it work. I don't know how it works on Ubuntu or other operating systems, to be honest.
Yeah, Michael, it's really interesting. So you don't expect such a change when switching from one OS to the other, but it's always the little things that break stuff, and then you have to find out the reasons for it. So the funny thing is, Michael, so this podcast we talk a lot about the very basic AWS service EC2. I will continue with the same service. Because I also looked into EC2 and I looked into the EC2 instance types again. So I've been doing that many years ago. Basically, back then I've written a blog post which was basically going through all AWS regions and checking which instance families are available in which regions to get an understanding which of the instance types are available in all regions or in most regions. And I thought it is time to update this blog post. And not only that, it's also important for us because of our products, bucketAV and attachmentAV. I wanted to know about the current situation in all the regions. And so I did basically update my tool that basically iterates over all regions, asks about all instance types in those regions from the AWS API, and then updated the blog post accordingly. And I think I wanted to share here a few things that I've learned about instance families and instance types in the different regions that I wanted to share here. So first, there are 8 instance families that are available in all commercial regions. So, Michael, these are C6G, so a Graviton instance type, I3EN. I've never heard about that before. I4I, same, I've never used this instance family before. Then M6G, another Graviton instance, M6GD, R6G, all Graviton instance types, and then it's T3 and T4G. So those are the only 8 instance families that you can spin up in all the commercial AWS regions. And one thing that is interesting here, for many years, the M5 instance family was the go-to instance family if you wanted to have a safe bet that was available in all regions. And that's no longer the case. It's then also interesting to see how long does it take AWS to roll out new instance types in all regions. And this can be quite slow. So for example, exotic instance type like I7i was released in April this year, and it's only available in 9% of the regions globally. And an older instance type, M7i, so the latest Intel CPUs, was released in August 2023 and is still not available in all regions. So yeah, AWS is not really fast not for all, but for many instance families to roll them out in all regions. And also what is maybe what you expect, the new regions and the smaller regions, like for example, AP East 2, they support only a very small subset of instance families, only 25 instance families in this region. And last but not least, I then thought I wanted to check if all the instance types of an instance family are supported in every region. And that's not the case. So there are exceptions to that. In some regions, you cannot get typically the very large instance types of an instance family are just not available for you. Sometimes also the metal instances. So I've summarized all of that in a blog post, and I have now a script that I can use to update the blog post easily. So I hope that I can regularly update this blog post in the future. There's one table in the blog post that shows the region coverage by instance family, where you get a percentage of how many regions how many regions do support a certain instance family. And I think that's very useful if you have to roll out something to many different regions, or like us, if you sell a product that people spin up in the AWS accounts, you need to know about those instance family availabilities in all the different regions. Yeah, so that's what I've learned about EC2 instance types and families.
Yeah, that's a good point, Andreas. And it's also like important if you like have this idea that you could, in theory, fail over to a different region with your workload. So you should check if the instance types are available, for example.
Yeah.
And otherwise it gets tricky as well.
I forgot to talk about one thing. So it's interesting that the Graviton instance types are those that AWS pushes to all regions. So they seem to be very behind that. And Intel and AMD, the latest generation of those instance types, they are lacking behind substantially. So that's maybe also an interesting trend to observe here.
Yeah,
it might.
That's right.
Probably has something also to do with the instance types and families AWS uses for their higher level services themselves. That's what I guess, why they have those available in all regions. But interesting. And from that, Michael, from this basically findings, I have then updated our products accordingly. So for bucketAV, for example, we switched from the M5 large to the M6I large as the default instance type that we recommend to all customers, and that is also hard-coded in the CloudFormation templates that we ship. So this is an important learning for us, because it increases the chances that the customer can just spin up the stack with the default values by changing the default here. And then the other thing I looked into, and I did some performance benchmarks as well, is for HyperEnv. So for our product that spins up GitHub runners on AWS on demand. And this was also an interesting, so I took also the learnings from the regional availability of instance families to that. And what I found out there is that using the latest available CPU generations of the EC2 instance types, for example, the M7A large, the AMD processors, can definitely reduce the build time or the runtime of your GitHub jobs by up to 29% in my benchmark results. So this is also an important thing, and I've updated HyperEnv to include all those latest instance types as the latest CPU generation, so that our customers can make use of those performance gains as well. So that's the other thing that basically came from that research and made it into our products.
Yeah, and if I remember correctly, Andreas, the bucketAV performance also increases, right?
Yes. Yeah.
I don't know if it was 10% or something.
So that's also interesting. Fun fact, Michael. So the M6I large instance, I think on demand is the same price for the instance as for the M5 large, when I remember correctly. But you gain a performance improvement about I think 15% is what I've measured with bucketAV. But the interesting thing is the spot instance price is a little higher. So it's around 10 to 15% higher than for the M5 large instances, as far as I can tell from the history data that AWS provides. So there the performance benefit gets basically eaten by the cost increase that you have from switching to the new instance, but still it's a little better compared to the M5 large. Yeah, so that's also interesting. Not only the on-demand price is important for bucketAV, as we rely heavily on spot instances, also for HyperEnv, by the way, the spot price is also important, and that differs probably also between regions. I've only checked it in US East 1, so might be different in other regions.
All right. So Andreas, you already talked a little bit about your content that you created, like the large tables of availability of instance types and families. You also reported on what you worked on by changing the defaults actually of the instance type for our products, bucketAV, HyperEnv, and AttachmentAV. So we have one question from Ben. I think we can answer that now before I talk about what I worked on, or does that make sense?
Yes, let's do that.
All right. So let me answer your question, Ben. So you ask that you heard that we use Terraform with marbot, and if this is our preferred infrastructure as code tool. So let me quickly, basically two questions, right? So what are we doing with Terraform and marbot, and what is our preferred tool? So in marbot, what is marbot? So marbot is a simple tool or a monitoring solution that collects the important events in AWS and sends them to Slack or Microsoft Teams. So for example, if you install marbot, you select an AWS account, you connect it with your AWS account in a region, and then to get all this information out of your AWS account, we need a couple of event bridge rules, for example, that send the data to an SNS topic, which then fans it out to our API. So this configuration, like SNS topic, event bridge rules, maybe some CloudWatch alarms, this is created by Terraform. So basically, for each and every customer account region that we have a Terraform state file in S3, and then we run Terraform apply for each of customer account region combination and see if we have to make any changes to their configuration, which means should we create new rules, should we remove something, should we create an alarm, should we remove alarms, and things like that. So that's done by Terraform. And simply because Terraform is very flexible, you have data resources, you can fetch a list of all the EC2 instances, and then we can apply cloud alarms for each and every instance, for example, and things like that. We can look at the tags. We can exclude if there is a tag marbot set to false, things like that. So this is very handy when we use Terraform, and there are no limits to resources, right? I mean, it works for 10 resources. It also works for 1,000, 10,000, and so on and so forth. So that's why we use Terraform in this case. And the Terraform apply is actually run inside a Fargate task. So that's why we have so many Fargate tasks, because we do this every hour for every account, region, customer that we have. And that's, I mean, if you have, for example, imagine you have 1,000 customer account region combinations, then you run 1,000 Fargate tasks per hour, which means 24,000 per day, which is 24,000 Elastic Network interfaces created per day, multiplied by 4. You have 100,000 config records per day created. And that's why we had such a huge config bill, basically. All right, so that's the marbot part. So Andreas, what's the preferred infrastructure as code tool these days for you?
So Michael, that's a funny question. So for many years it was CloudFormation. Then I did a lot of Terraform. We also started to use CDK to generate CloudFormation templates for our products to simplify and be able to reuse parts of it. So basically now we're using, I would say, all the three popular ones, CloudFormation, because also we can use it very easily in the marketplace, in the AWS marketplace. That's a reason for that. It's very easy to use for people that are not into infrastructure as code yet. They can simply spin up the template. Terraform is, I think, very flexible, very popular, still a good tool. And CDK has become handy to generate the different versions of our CloudFormation templates as well. So I would say nowadays we pick the tool that fits best for the job that we do. So I personally don't have a go-to tool anymore. I think all of them have their pros and cons, and yeah, it's not that easy to do everything with one tool anymore, unfortunately.
Yeah, but I have one observation, Andreas, that I just made yesterday. So I have a very old project that I use for personal stuff, basically tracking expenses of my private expenses. This is a PHP code from I think 15 or 20 years ago, right? It's really old application. And it has a code pipeline described in CloudFormation, and it's connected to code commit, which is not available anymore, right? So I just pushed something yesterday, and imagine what happened. It just worked. Yeah. The CloudFormation template is maybe 10 years old. The code pipeline is I don't know how many years old. Yeah. I pushed to a very old code commit repository, and it just deployed, and it was green. Yeah. I mean, that's not going to happen with Terraform, right? I mean, if you have your 8-year Terraform code, you run Terraform apply. I mean, you need your Terraform version changed from version 0.4 to I don't know what the current version is. Everything explodes, and yeah, that's true. I mean, that's really a point for CloudFormation, right? Yeah. It's really stable. I mean, it's reliable. It works. Yeah, it's really stable. That's for sure. Yeah, you're absolutely right. Yeah. And maintaining Terraform is a lot of work. So I use Terraform together with TerraCrunt in the project that I'm doing. It works well, but it's really painful to keep it up to date. If I touch a project that I haven't been working for a few months, I'd have to update a few things before I can start working on that again. Yeah, so that's probably a point for. Yeah. I mean, I like CloudFormation and I hate it.
Yeah, that's probably true for all the tools you use, Michael.
Yeah, that's right. So I think there's no best tool, to be honest. So if there's something that is actively used, maybe Terraform is better. If there's something that's touched every couple of months or every couple of years, then CloudFormation likely is better. But
yeah. And you can get the worse maintainability from Terraform with CloudFormation if you use CDK. So then you have both worlds. You update all your CDK modules and the CloudFormation. Yeah. Okay, Michael. Maybe let's. I hope that answers the question. And maybe let's go on with the next topic.
Next topic. Okay, what I was working on. This is not AWS related. This is more kind of a risk thing. So with bucketAV, as I already mentioned, I think we are scanning customers scan their S3 files for malware, and they use either the ClaimAV engine or the Sophos engine. And those engines rely heavily on what's called a signatures database. So this is basically a long list of hashes of files that are known to be malicious. And if they find a file that matches the hash, they say it's infected. So very simplified explanation of how such an engine works. I mean, it's definitely more complex if you look into archives and into PDFs that have images in it and things like that. But as a simple model, this is how those tools works. So a couple of months ago, Andreas, we questioned ourselves basically, what's the worst thing that could happen for our company? And one thing that is really bad is we could just wipe out the data from our customers, right? So customers scan their buckets on a schedule, for example, monthly. And if we manage to kind of destroy the signatures database in a way that just flags any file as infected, basically our customers would delete all their files. I mean, they would not delete them immediately, but over time they will empty their buckets, basically. So that would be very bad, Andreas. So that's why we thought, okay, how could we make that more secure? And what we did and what we implemented in the last month is that we basically, when we receive a new update of the signatures database from our engines, ClaimAV or Sophos, we run them against a known set of clean files and a known set of malicious files and check if they still detect the malicious ones and still don't detect the clean ones. And if they do, we push this update to our customers. If something is not working as expected, we just stop the synchronization process of the signatures mirrors that we run for our customers. And this way we can ensure that if the vendor for some reason publishes a broken signatures database, we would definitely not mark all the files as infected from our customers. And this, since I know this problem, I don't sleep that good. And since I released those checks, I sleep better. So, because this was really a big security risk for our customer, or a data risk for our customers.
Yeah.
And now it's fixed, and now I'm very happy about it, Andreas.
Yeah. Yeah, that's really cool. So it's basically having a test implemented into the update mechanism. That is another layer.
And I think there was this vendor, I cannot remember the name, about it was this beginning of this year or last year, but basically they pushed a broken configuration and it basically stopped all the Windows machines in the world. Was it, I don't know how the company was named, but this is something like this. Yeah. So we hope it's not going to happen because of this mechanism.
Absolutely. Okay, Michael. So let's finish the episode with a win and a fail. So I'll start with the fail. We as we've mentioned many times, we sell many of our products through the AWS Marketplace. And for some of our products, we have decided to use a new feature of the marketplace, which is called metered billing. So basically what that allows us to do is our customers launch bucketAV in their AWS account, and the EC2 instances that run bucketAV, they report usage, for example, how many data has been scanned to an AWS Marketplace metering API. And then we are charging based on this metric, for example. So we rely on that feature. We decided to do that because it seemed to make sense, and we wanted to try out the new possibilities in the marketplace. So the bummer is now that it seems that we are almost the only one who uses the feature. And that's not correct, of course, but most of the independent software vendors do not use the metering API. And that is why AWS decided, we will not roll out the metering API to the new regions anymore, at least for now. And so all the new regions starting in December 2023, or many of them, they do not support the metering API. And AWS says, we are not sure if you're going to ship the metering API to those regions in the near future. So we are in a bad situation here because we basically cannot provide our customers the service in those AWS regions anymore. And so we made a decision to use the feature, and now we are kind of stuck. So that's a little bit a bummer and a fail.
Yeah, that's right. And it's actually one that we cannot easily kind of resolve,
Nope.
right? Because we are 100% reliant on AWS to ship that. And,
Yes.
and if they don't, I mean, yeah. That's bad.
Okay.
All right, Andreas, I have a win to share. So we have a product called AttachmentAV for Salesforce, which scans files on Salesforce for malware and viruses. And we have a new customer going live this month as well. And now we have, we're protecting over 300 users from viruses, Trojans, and other kinds of malware on our AttachmentAV for Salesforce product, which is one of the more recently launched products.
Yeah.
Which is very cool.
Very cool. And Michael, based on that, I also looked into the whole AttachmentAV product series and I checked. So we scanned more than 1 terabyte of data this year already. And AttachmentAV also found about 2,000 infected files while doing so and protected our customers from those files being accessed. So I think that's not too bad. I'm quite happy with those results. And it's really cool to see those AttachmentAV products grow as well. So cool.
Yeah. Great.
Okay, Michael. So I think that's it. We'll be back soon. So subscribe to the cloudonaut newsletter, podcast, or the YouTube channel to make sure you're not missing the upcoming shows. Also, we're looking forward to your feedback. hello@cloudonaut.io or find us on LinkedIn and Mastodon.
All right. You will find all the links in the show notes or in the chat. Thanks for joining us. Have a great day. Bye.
Bye.